So, most fuels that we have today are obtained from crude oil. Which statement about crude oil is correct? So, crude oil is a compound. Crude oil is not a compound. Crude oil is a mixture of different length hydrocarbons. Crude oil is a mixture, so that's okay. Crude oil contains different hydrocarbons, all with the same molecular formula. That's not true. And let's get rid of that. Crude oil, that's not true. Crude oil is unlimited supply. No, crude oil is a finite supply. It will run out. So the sensible option in there is option B. Crude oil is separated into fractions by fractional distillation. Two of these fractions are kerosene and diesel. Give a use for these. So kerosene is used as jet engine fuel, so for aeroplanes, and diesel is used as a fuel in larger vehicles, for example lorries. 1 mark for each one. So here we've got our fractions. It says choose a property for kerosene and compare it to this. So we've got kerosene's obtained. Kerosene have slightly different boiling points, so we have to therefore explain choose a property, state how the property of kerosene compares with the property for diesel. So if we pick boiling points, we can say that as we go up the column here, the fractionating column, the hydrocarbon molecules actually become shorter, and therefore the melting and boiling point, so I put boiling point here, will decrease. So the first thing I can say here is the property is the boiling point, and I can say that kerosene has a lower boiling point. 1 mark for each of the points, and 1 mark in total, so 1 mark for getting both right. Okay, explain how they are members of the same homologous series. So one of the rules of homologous series is they change by a CH2 group each time. And if you look at this, this fits with this formula because butane is C4H10 and pentane is C5H12. So the first one we can say here is they differ from each other by a CH2 group. There's the first point. Second point is that they have, because we've got to base it just on what we see in front of us, they have the same general formula. We don't have to tell them that, but we can show off because we know these two are alkanes, and the general form for an alkane is CnH2n plus 2. Okay, next one. Butane has got this formula. Calculate the mass of just carbon in 100 grams of this. Okay, so we're told the relative formula mass of butane is 48, and in that 48 we've got 4 lots of carbon atoms, which is 4 lots of 12, which is 48 for the mass of carbon. So if I do 48 divided by the total mass of 58 and then multiply it by 100, I'm getting an answer. Let's just put it into my calculator. I'm getting an answer here of 82.758, so on, so on, so on. The question says, and be careful, 3 significant figures. So 1, 2, 3, 4. Because this one here is 5 or greater, then what I'm then going to do is add 1 to that 7, so that's going to become 82.8. There's 3 marks in here, so I've got 1 mark for giving it as 3 significant figures. I've got 1 mark in here for doing 48 divided by 58, and then another mark for timesing it by 100.